Hello, today we will be talking about freshwater zoogeography. Now in the previous lecture we talked about zoogeography as a topic, kind of introduced it, looked at the factors that influence distributions. Now we're going to look at freshwater ecosystems in particular, and we're going to specifically examine those for the distribution of fishes. So we'll look at the major freshwater zoogeographic regions, and we'll talk about the distributions of fishes within those regions. So to start with, freshwater. What exactly is freshwater? It's the water that doesn't have any salt in it, right? About 41% of our fishes are freshwater species. That's close to half. That's a lot of fishes. But only 0.0093% of the Earth's water is actually freshwater. This means that nearly half of the fishes that we have live in less than 1% of the world's water, which is kind of amazing when you think about it. If you look at the typical species, like for the average marine species, has about 133 cubic kilometers of space available for it throughout the whole ocean. We divided the ocean up and gave each species its own equal-sized piece. The average freshwater species only has about 15 cubic kilometers of space. And part of this is the idea that there is a lot more seawater, right? Marine habitat is a lot larger, but what of that habitat is actually usable? Freshwater tends to be shallow, especially compared to the oceans, and productive. So the majority of freshwater is going to be in that photic zone, where we can have that primary productivity, right? We can have the phytoplankton, the base of the food chain. And if you can start with the primary productivity, then you're going to build up. You'll have your phytoplankton, you'll have your zooplankton, you'll have your smaller fish, you'll have your invertebrates. You can have that complex food web that has room for lots of different fishes to be in it. Marine habitat does have shallow areas, but a lot of the marine habitat is deep water, and that may limit the number of species there. So if you're looking at total habitat, just marine versus freshwater versus the more usable habitat, that's a little different. But it's still amazing when you think about the number of fishes that are found within freshwater. And I'm talking about freshwater fishes, and we should probably stop and clarify what exactly we mean by freshwater fishes. Yes, they're fish that live in freshwater, but it's not as straightforward as that. We can have primary freshwater fishes. And this is what you'd think of when you think of a typical freshwater fish. There's no saltwater tolerance. They're found in freshwater. They don't cross over to saltwater at all. They don't skip through a little bit of the ocean to get to the next stream. They're found in freshwater. We have secondary freshwater fishes, and these are fishes that have some saltwater tolerance. So they have that ability to live in a little bit wider of an area to cross into that marine habitat, at least on the edges. And we have peripheral freshwater fishes. So a peripheral fish is one whose ancestors were marine, but is now freshwater. It can also refer to a fish that spends part of its life cycle in freshwater and part of it in the marine environment, those diadromous fishes, right? We have some that live in the oceans and breed in the freshwater. We have some that live in the freshwater and breed in the marine systems. So there's two different kinds of peripherals. We've got the diadromous fishes, and we've got the ones who their evolutionary ancestors were marine, and then we've got primary and secondary freshwater fishes, just to confuse us a little bit. We also have to mention island fishes, because this is just kind of cool when you think about it. We have different types of islands. So we have continental islands. That would be like Trinidad down here, this little guy. At some point, it was attached to a larger landmass, right? When the ocean levels, sea levels were lower, Trinidad would have been connected. So Trinidad will have the same freshwater fishes that we see on the mainland, because it shared that at one point. But our oceanic islands, they never were connected to a continent. So this is things like Bermuda, Hawaii. So they don't have any native primary freshwater fishes, right? It's not that they don't have freshwater fishes. They just don't have native primary. So all of the native freshwater fishes are either secondary, so they have some tolerance for saltwater, or peripheral, where they have ancestors that were marine, or they're fish that live part of their life cycle in the ocean and part of their life cycle in freshwater. So it's kind of interesting. We have to stop and think again from a geologic perspective, the history of that island to figure out the background of the fishes. Freshwater zoogeography in general can basically be explained by continental drift. that we talked about in that first lecture. Because when you look at it, we're talking about the fish that are found on land. So when you look at the continents today, it's not like the fish here in Virginia, the freshwater fish, are going to leave our rivers, our ponds, swim across the ocean, and be found in Europe, right? That's just not something a primary freshwater fish can do. So our distribution is largely a function of continental drift. And we'll see that as we talk our way through the various areas and then the various groups of fishes. So we have those general large areas, right? We have the Palearctic. This is kind of our northern part of Asia and into Europe. We have Ethiopian, which is African. It's also referred to as African or Ethiopian, most of the African continent. We have our Oriental, which are those little bits over on the end. We have our Australian section. And then over here we have the Nearctic that we're part of, and that's from Mexico up all of North America, up including Greenland. And then the Neotropical section, which is from about the middle of Central America there down into the whole of South America. We'll work our way through the regions briefly, just kind of highlighting the major differences between them. So if we start with the African region, okay, the African or Ethiopian region here, this dark part, we see a lot of species. We've got about 2,500 species, mostly primary and secondary. 27 families are primary families that would have been freshwater species always here. And when we look at the diversity, we see lots of those osteoglossomorphas. So that's one of our earlier ancestrally lineages. And some of these are archaic, and we'll talk about archaic distributions at the end after we work our way through the regions. We have cichlids, half Asteriophyzons, Cypriniformes, Carassiformes, Siluriformes. You remember what these are, right? We have our catfishes here. We've got like 360 some species of catfishes. We've got our minnows, over 300 species. We have our characians here. These include our piranhas and our tetras. So we've got a pretty big variety of fishes. Now the neotropical region, so this would have historically shared borders, right? They would have been together. So this is South America, over 2,600 species. And it varies on that. Your book says over 4,000 have been described, and there's 1,500 waiting to be described. That means that we just don't have an official scientific description and that scientific name given to all of them yet. South America has the largest freshwater fauna in the world, and we're exploring that and trying to figure out all of the different pieces of it. 32 primary families, mostly Asteriophyzons, but now we don't see any of those Cypriniformes. So those are our minnows and suckers. They're not there at all, but we have 1,200 Carassiformes. So these include, again, our piranhas and our tetras. So these 1,200 fishes are probably the ecological equivalent of those minnows and suckers. And the diversity in here is filling those niches. 1,300 Siluriformes. These are catfishes. And we have lots of peripherals as well. Lots of marine families have invaded the freshwater in this area. And it includes a bunch of different species, including things like our freshwater stingrays. They're found in South America. So even the marine rays have invaded the freshwater environment in the neotropical region. Moving into the Palearctic region. So now we're in Northern Europe and Asia. 14 primary families. Lots of Asteriophyzons again, some Siluriformes, some of those catfishes. We see persids and pickerels as well. We've only got a few of those catfishes, about 10 species, not as many families as we saw right when we were talking about that very diverse neotropical area. Europe historically was thought to have really low levels of fishes, not to have very many native ones at all. But when they did recent surveys in 2007, they found over 500 native species of fishes in there, and more endemic species in the south. So remember that endemism is the idea that you're native to that area, and that's the area that you are found in, suggesting a kind of a local fish. Nearctic region, so that's us. That's most of North America, again, up into Greenland. 14 primary families, around 950 species, so not too bad, but we're not near as numerous as we saw in that neotropical region. Mostly Asteriophyzon, if we're looking at the major groups. Those are Siluriformes, Cypriniformes. We also have perches and darters and lots of sunfishes. Those centrarchids are really numerous here. When you look at it in detail, they actually divide it into 3 subregions and 12 provinces. You can see some of those numbers in there. We're not going to go into detail on all of those, but I will point out one province, the Southern Appalachian River drainages, and they're home to about 350 species of fishes. That's the richest diversity of temperate freshwater fishes. So there's a lot of fishes in that area. Moving on to the next region, the Oriental region over here, kind of Southeast Asia. Over 1,700 species of freshwater fishes, mostly Ostariophysin, but we also have the snakeheads that are in there, the spiny eels. And if we talk about the Oriental region, we have to bring up Wallace's line again, right? So that's that line in here that seems to be the border between those Western species. That's as far as east as those Asian species go. And there's the line, so we don't see the crossover between those Asian species, Southeast Asian species, and those Australian species. There's just seems to be that dividing line, and we see that even with the fish. Like we said, it's not just that there's that 35 kilometers of open ocean, it's that there seems to be enough of a trench, enough deep water there that keeps our fishes separate as well. And then the Australian region, that's the other side of Wallace's line there, down here. And Australia is interesting in terms of freshwater fishes. We have 3 species of primary fishes, 3 native, truly freshwater fishes in Australia. And they're all archaic, lungfish and 2 of the osteoglossids. We'll look at archaic species again in a little bit. There are actually lots of other freshwater fishes. It's not like if you go there and look in the rivers or look in a pond, you're only going to find these 3 kinds of fish. Those are the 3 native primary species. We've got lots of peripheral freshwater species, and probably by now a lot of introduced species as well. Over 330 peripheral freshwater species are found there. So there is a high diversity of fishes, just only 3 that are truly primary native Australian species. So I keep talking about archaic freshwater fish distributions. And what that basically just means is that the present distribution may be based on a different arrangement of the continents. We've already talked about this, we just didn't give it an official title, right? We've talked about the lungfishes here, the dipnoi, and how we find them in, let's see, we find them down here. We find them in South America and Africa and Australia. And these are freshwater fishes, so that means they're terrestrial fishes, right? They're not swimming across an ocean. And we can see where that distribution could have happened when the continents were connected. We see this in other of our kind of primitive groups, those older groups that we talked about, the first groups of fishes, we refer to those as the primitive groups or the ancestral groups. And all that basically means is they're old. They've been around for a long time. So given that it takes a while for the continents to move, it would make sense that these older ancestral primitive groups are the ones that have this archaic fish distribution. We see it in the lungfishes, the Polypteriformes, the Polyodontidae, Lepisostiidae, Ameidae, Osteoglossomorphus. Hopefully those names are not totally foreign to you and you have some idea what I'm talking about. We'll look at a few examples. We'll start with the Polyodontidae. So poly, many, odont, teeth. This has to do with our paddlefishes. And remember when we talked about paddlefishes, when we were talking about our earlier groups of fishes, and we talked about how there's 2 species. We have our North American paddlefish that's found in the Mississippi River drainage, and there's a Chinese or Yangtze paddlefish that may or may not still be found in China. That's, as they put in more dams, it's decreasing their habitat. But did you ever stop and think that these are 2 freshwater fishes? They're related. One is way over here in China, and the other is stuck in the middle of the United States in the Mississippi River. How did those 2 fish evolve to be, they're related, so they came from the same ancestor. But how did they get where they are? Did they swim out of here and then, I guess, all around South America and over to China, or the other way around, or swim over and find some rivers to make it to the Mississippi? Probably not. It's probably because of where they were, where the continents were when the fish evolved. And at one point, right, let's see, North America here, right, as part of Pangaea, and Eurasia were connected. So their rivers would have been connected and they could have shared the freshwater fauna at that point. So that's probably where the paddlefish evolved from, right? That explains their distribution by looking at the way the continents used to be arranged. Acipenseridae, so we can do this as well with our sturgeon, right? Our paddlefish's friend. We see that same type of pattern where it's found throughout all the northern continents here. And again, when we had Pangaea, those northern continents were connected and would have been sharing that that fauna. There's 27 species of sturgeon, so there's a little bit more diversity, but they're spread across the northern parts. Again, freshwater, we're not in the oceans here, right? We're on the land masses. Osteoglossidae, so we see these in our southern continents. So now this is kind of the other side. We have 6 families, but we have genera from different continents that are in the same family. All right, so we have our family, and there's a genus from that family in South America and a genus from that family in Australia. Freshwater, so again, we're not swimming across the ocean to get back and forth. It's because in the geologic past, the land masses were connected. And you can see that, right, where we've got the Osteoglossidae, they're found in South America across the middle of Africa, and then here in various islands and Australia, all of which at one point would have been connected together and then separated. These are 2 of the endemic freshwater, native primary freshwater species of Australia. The lungfish that we talked about before, he's one of the others. And we see that same distribution in the lungfishes, right? They're not up in this part, but they are in these 3. So we'll move from archaic distributions to recent distributions. And notice the star with recent. Recent is not like yesterday or last week or this morning. It's geologic terms. So we're talking still millions of years, tens of millions of years. So recent distributions are ones that came after the breakup of Pangea. So it's not the whole thing that's connected where we see fish that kind of move through all of Pangea. Pangea is broken up, but we still have Laurasia, so the northern continents are still together, and Gondwana is still together. So we're now about 120 million years ago. So, recent, just last week. And you can see that just by looking at the names, right? We see the similarity between the northern continents. We have our Isocidaes and our Persidaes. And then we see the similarity with our southern continents there with the cichlids. And you can see the more widespread distributions for fish that would have moved back when it was still Pangea, like those Siluriformes and Cypriniformes. We see those spread, Siluriformes across everything. Cypriniformes almost, they get bumped out there in South America. But you start to see that freshwater fishes and how they would have evolved together, how those lineages are linked when those land masses were all together from a geologic perspective. Recent distributions are things like our Isocidae and our Umbra. So these both are showing that distribution linked to certain areas. So with the Isocidae, so this is looking actually at our northern pike, and the northern pike has the broadest natural distribution of any fish in the northern hemisphere. He's found just about anywhere, if you want a river in Russia or a river in Europe or the United States, up to Canada, up into Alaska. So they have this big distribution, again, from when North America and Eurasia were connected. We see it also with Umbras. So these are both the Isociformes, right? We have our pikes and pickerels, and we have our mud minnows. So Umbra is a mud minnow, and they're the little guys. We have them in the United States, you see here in the shaded areas, and there's one relic species in the Danube River in Europe. So again, you can go back to when they were connected, and that's when they would have changed, would have evolved. And then as the landmass is separated, we'd have different species on each landmass, that vicariant dispersal event. Both of these examples, again, are those Isociformes. And remember, that was one of those early teleos lineages. The Isociformes were ones we couldn't quite figure out where they went. When we went into teleos, Salmoniformes and Argentiformes are 2 of the first groups that kind of break out. And then we take the Isociformes and we kind of put them with the Neoteleos sometimes, and sometimes they go with the Salmoniformes, and we're not really sure where they belong. But they're one of the earlier lineages, so they would have been around longer, so it makes sense to see that distribution in these older lineages. We can also see this with the cyprinids, right? We see them throughout North America and throughout Asia as well. And you see it with even going down into Africa here, but South America was by itself for a long period after it kind of separated. And you can see that with some of it where it has its own unique fauna for some groups. Cichlids, that's an obvious one we can see very nicely between our southern continents that would have been stuck together. Australia and Antarctica broke off, and South America and Africa kind of shared their connection for a while. And we see that definitely with the cichlid distribution. We do need to talk about Middle America for just a minute. So North America and South America were separate till about 3 million years ago, and then they finally connected. So South America kind of floated around by itself for a while before it was made that connection. We tend to not think about that South America is that part there, right? And Central America and Mexico are part of our landmass, so we share more things in common than South America does. So Middle America kind of has this weird role that it plays. It acts as a filter barrier to movement. We see this with fishes. So this map shows you the northern limits of southern families, how far up they've made it. We've got 2 that have made it up to kind of the Rio Grande area, right around the Mexican-US border. And we have a few that have made it from the southern limits of our northern families with the dotted lines. A few have made it down to about the Costa Rico area. So you can see where they're moving, and we have this, and we get this interesting mix of species. It's kind of an unusual group, and it's not something we see other places. And it really needs more study to figure out if the fishes of Middle America here are northern in origin or southern in origin, or if it's a mix in which groups are competing each other out. By being independent for a while, South America has its own evolution in there, its own groups of fishes. And when they connected, now those rivers and streams would allow fishes to move between those 2 land masses and kind of create a unique and different group of fish. The other thing to note that has nothing to do with freshwater fishes, but will come up in our marine discussion in the next lecture, is that before North America and South America connected, the oceanic currents, right, could go east to west there. So we didn't really get the Gulf Stream until those 2 continents touched, and that made the ocean have to change its circulation patterns. So the land masses moving from the freshwater point of view just allows the fish to move from one land mass to the other. But as those land masses move, we're also changing conditions for the marine species. And again, remember, it's not like in one fish's lifetime, suddenly those 2 continents bumped up against each other. This is happening slowly over millions of years and multiple generations of fishes, so that they're evolving slowly to adapt to the changes in their environment, or they're not evolving to the changes and they're going extinct. We'll end with a weekly review question. We've been talking a lot about the different factors of zoogeography and the things that influence where fishes are found. And one of the things we talk about is Wallace's line. And this is kind of an important concept. So just briefly tell me, what is Wallace's line and why is it important to zoogeography? And like with all of your weekly review questions, add that to your list for the week and send it to me in email by midnight Saturday. Thanks. This was zoogeography. We've made it through the factors influencing distributions in the previous lecture. And this one, we spent a lot of time looking at freshwater zoogeography. We talked about the various regions, and we looked at distributions, specifically of some of our archaic lineages and then some of our more recent lineages as well. We'll come back and touch on the marine zoogeography in the next lecture. As always, if you have any questions on today's material, please let me know. Thank you.